Hello, today we will look at ANOVA versus linear regression and when are we using each of those. So linear regression is used to predict the value of a dependent variable from one or more independent variables that best fit a linear model. The ANOVA test is used to test for a statistically significant difference in means when there are three or more categorical independent variables or groups. Um, and let's just take a real world example to look at an ANOVA test. So let's just say an organization has launched a new product tier, and we want to look at satisfaction scores based on each product tier. We have basic, standard, and premium product tiers. So we assign some scores on a 10-point scale to those product tiers and create a data frame and group those scores to the appropriate to the appropriate product tier in the data frame. And we run our ANOVA one-way test. So our null hypothesis is that all of the means of each category is equal. The alternative hypothesis is, though, that at least one group has a statistically different mean. So that's why we're running a one-way ANOVA test for each of the groups. We will print our p-value and F statistic. If the p-value is less than 0.05, we will reject the null hypothesis because there is a significant difference found. And if it is more, then we will fail to reject the null hypothesis. We'll also look at a box plot to see the spread of customer satisfaction across each of the product tiers. So as we look at our F statistic, the p-value for that is 0.002, which is less than the significant level of 0.05. So therefore, we must reject the null hypothesis because there is a significant difference in satisfaction scores across the product tiers. As we look at the spread here of basic compared to standard and premium, we do see that basic is much lower. There is no overlap in scores, so that supports our findings from the hypothesis test. So that's a quick glance of how ANOVA table testing works.